Well, hey everybody, welcome to another episode of Exam Prep Wednesday night, where we test your knowledge of the National Electrical Code. You notice something new tonight, folks? We have a code cam. Code cam. Code cam. Ooh, right there. Code cam. Okay. I'm having too much fun with this. All right, welcome. Hopefully we're going to look at some code tonight. You're going to ask questions. You're going to post them in the chat, and we'll try to answer those questions for you if we can. If you got any that are just pressing for you and you want us to try to answer, we'll do our best. Let's keep them to the facts of code in exam preparation. Don't ask me the secret to life, because again, I have no secret to that. I like that music on in the background. Everybody thinks I'm getting all funky with that. But no, we'll get rid of it. So, thank y'all for coming. We have a good group, looks like tonight. There's 17 people in there, at least right now. Don't be shy. Don't be shy. Speak up. Let me know who you are, where you're at, where you're from. Let me know that you can hear me okay. Don't let me know if it's like overmodulated or something like that. I can turn something down. Kind of... You know, we're just going to chill it out here tonight. Got the code book, as you can see right here. Got it zoomed in. Of course, we have the code book on the screen as well. And, of course, y'all have the chat that you can chat and ask me any question you want to ask on any topic you want. So, we can do that. So, first things first, while people are filling in here a little bit. Exam preparation, there's a lot of people that are taking their exam in the next 2 weeks. I'm getting a lot of emails. Again, when you get to about that week out, okay, and you want to start doubling up on your exam questions, and again, we want to remember what I said. When you get down to the last 2 weeks or so before an exam, there's when you want to start timing yourself. Okay, get your timer on your phone. Okay, and set it at 2 minutes, and be methodical on your question. Set your 2 minutes, start it, and then look it up. Okay, and if you don't do it in 2 minutes, that's fine. But again, kind of get in that mode, right? Last 2 weeks, last week, for those that are in the Fast Tracks program, you definitely want to start hitting some of the actual practice exam question stuff down at the actual bottom of your console. You definitely want to do that. People that are in a Fast Tracks program ask me all the time, is it just the course material? No. I need you to also be doing the stuff at the practice exams and things like that. Okay. Gustavo, got your code book ready. There you go. Got it all tabbed up. There you go. You see my tabs on here. Got them all tabbed out. Not real happy with the easy tabs this time. They were not very good. But it is what it is. I'm trying to get my own tabs done, but it's becoming a bear to find somebody that can make these tabs that I want. So there are plenty of them out there. So I did have somebody ask me if I would create tabs just for tables. Now, you know, you've heard me say I don't believe in over tabbing. But somebody did ask me if I would give them a recommendation on what to do, some tabs that just are the key tables to have. And you know what? I cringe to say this, but I guess he could put them across the top or whatever, you know, all white, just for tables, so that you're not over analyzing it. What I mean is, too many tabs about code references articles get you screwed up. But if you had some tabs that tell you significant tables, then again, it might be helpful. Again, depending on the state you're in, what's allowed. Again, everybody tries to, you know, no offense, Gustavo, but everybody tries to remind me. I think most people know I'm pretty versed on the fact that some states you can't write in your book, some states you can't tab, some states can. It's your responsibility to know whether or not you can do it in your state or not mine. So check with your state. I'm going to always talk as if you can, and you're going to have to determine otherwise. It's your state. So find out what they want, whether you go to PSI or whether you go to whatever, that type of thing. So let that be your guide for whatever your state is, and make sure you check it out. Let's see here. So Jokester, thanks for coming. Jose, I'm going to say it's Jose. I'll call you Joker in Boston, up in the Mass. And let's see here. LM, South Africa. Cool. You go tabs only in Oklahoma. So Oklahoma, they let you tab. Let's see here. So Gustavo says, yes, definitely. Those that are in Maryland, Gustavo says that you cannot write in your code book in Maryland. Definitely. So there you go. Elwood, thanks for coming in. I don't know who this legend is. Anyway, thanks for coming. Okay, so let me get a couple things out of the way real quick before we start digging into this, because there's still been some confusion. And all of you that are new, you know, check out my new boop, 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 code cam. You'll see on our website, masterthenec.com or electricalcodeacademy.com, you'll see that I put up there a 60-day and a 90-day study plan. Now, remember, that's not a plan. I mean, you don't buy that, right? That is just a recommended study plan to use if you're a member of our Fast Tracks program. And you need to take your exam within 60 days or within 90 days, and I'm giving you a way to achieve that if you follow the plan. If you're a Fast Tracks member, you still get access to it for a whole year. Okay, so these are just study plans. Okay, and they're free. They're available for download on the website. But I will say this: you don't have to use the our program for that. If you want to use that and kind of modify it a little bit so that it can be used on somebody else's program, that's perfectly fine. They're for free, and you download them from the website. But again, I don't want people thinking, I had people contact me and say, hey, Paul, we want to buy your 90-day course or your 60-day course. And I'm like, we don't have a 90-day or 60-day course. We have a study plan to help you focus your studies. We have that. That's on our website. That's free. But you use it with the Fast Tracks program. Makes sense? I've been getting a lot of emails about that lately. I was like, maybe I didn't make that clear anywhere. So, again. Also, again, don't forget that we have that cheat sheet, if you will, for calculations. The first one, we're going to have multiple volumes of that, but that's the first one that's out. I'm just so bogged down right now with stuff that I'm doing the best I can. But that is a cheat sheet, and that's available for free as well. Just go over to, especially when you're studying, you know, print it out, keep it in your code book. That is over on our website, masterthenec.com. So masterthenec.com. Okay, so that's our website, and go over there and you can actually get it from there. I probably should put our website on here, shouldn't I? All right. So let's do this, because I'm sure people will constantly ask me. So let's do this here. thenec.com. How you like that? I'm doing it on the fly. All right, so let me grab this real quick. And there you go. All right, so there's the website right there. That's where you go, and all the helpful stuff will be right there for you to be able to do. So there you go, right there on the fly. Okay. All right, so let's kind of get into some exam prep tonight, and talk a little bit about the exam, look at some questions, maybe dissect it. Unless, of course, when I do this, I'm open for you all to ask your questions. So feel free to ask some questions if you have any, and feel free to write them out, post them, and we'll definitely try to answer those questions if we can. Again, sometimes people ask some really off-the-wall questions that there's no way they would be on an exam. So, you know, if your effort is to ask some kind of question that you know that's some off-the-wall question, don't waste everybody's time. Okay, you know what I'm saying? So look, ask your question. We'll try our best to answer it. But again, let's try to also keep it germane to, you know, exam prep. Okay. What else? That's it. So anybody got any questions? Feel free to post them away. So I should say hello, Angel. In North Carolina. Let's assume that's North Carolina. Angel says in North Carolina they provide you the NEC, so again, tabbing and all that's not going to do you any good. That's why people wondered why I took so long to tab my 2020. I only did the 2020 because of the video that we were doing. Normally I teach people without the tabs, and until it's time for them to take the exam. Or if I'm teaching something to somebody tutoring and they can't use the tabbed up book, then we won't use the tabbed up book. But tabs are great to help you maneuver, but again, they're kind of a crutch. You should be able to flip it and find what you need by looking at the top as you flip through, and you'll see the code sections and different things up there. So again, but if you're sitting in a state that lets you do this, do it. Why not? Not going to hurt anything, that's for sure. Okay. And hopefully, if you haven't tabbed your book, and you want to tab your book, you go watch that video that we did, that I did on how to tab your code book. Because I also have a little blurb in there about highlighting, and I'm not a big believer in highlighting everything. Okay, so you'll kind of see that. We'll kind of look at that. In fact, hold on for a second. We might do some of that tonight if we're looking in the code book. All right, let's see what else we got here. Too cool. Hello, thanks for coming as usual. Good to see you. All right, so y'all ready? Let's go kind of look. We're gonna lose our code cam, but we're gonna go to our program. We're gonna go to our browser, and let me get off of my music. All right, so we're in the 2020 program. And let's just go down here. Let's do, hopefully this will look okay on our screen, because I didn't check it out ahead of time. Looks like we've done a few in this one. So let's do another one. Let's try Master Electrician 1. And we've done a few in that one too. Let's try Master Electrician 2. Fresh. All right, we'll do some fresh ones. It's fresh, fresh, fresh as exciting and new. Sorry. Okay. Let's kind of get your screen up here so I can see y'all's questions. Trying to get a little oriented here. Bear with me. Okay. All right, so you've got your code book. We're on the 2020 code. If you have a 2017 code, don't be discouraged. Okay. still look it up. You know, chances are many times on exam you're not going to get a whole bunch of stuff that have to do with code changes. A lot of times we're lazy when we do code, when we write exams. If they're still relevant in the 2017, we're not going to rewrite everything for the 2020. We might add a few, but again, if they're still relevant, then probably going to keep them. Okay, so don't freak out or anything like that if you don't have the 2020 code with you, because that's what we're looking at tonight. So don't freak on me. All right, let me move this out here. All right, so here's the question. First question we were doing this would be, when determining the number of conductors permitted to be installed in an outlet box, a reduction of blank conductors shall be made for one device, two internal clamps, and 3 equipment grounding conductors. Okay, so preparing for an exam, a couple of things that I want to notice about this is, again, less looking up code, because at this point in your exam prep, if you read this and you have no clue, then you're going to be you're very early on in your studies at that point, because this is dealing with an outlet box, it's dealing with box fill. So one way to do it, go into your code book and go back to the index. We can do that. And I've got my code book, as y'all know, right here as well. So let me get this up here so you can actually hear me. And let's go on and go and say, let's assume you didn't know where to go. Okay, yeah, too cool, already knows where to go. He's thrown that sucker right up there and given me an answer. Okay. But for those of us that are less savvy, you like that? All right, we're going to go and look and see. Okay, well we have boxes, we have outlet boxes, and we notice that we're trying to determine a fill calculation. Okay, but then of course this question is asking us basically what are the number of conductors permitted to be installed in an outlet box. Okay, a reduction of blank conductors shall be made. So we want to know the certain number in a box. We have no idea what size the box is or whatnot. So the first part of the question could be very misleading for a student, because they immediately go, well, crap, I got to do something. I got to know the box size, right? They're like, I got to know this. But then it says a reduction. So the real part of the question is the reduction of blank conductors shall be made for, and then of course, obviously each conductor is going to have, each device, clamp, equipment grounds is going to take up a certain conductor. Okay, so where do we find this? Well, if you go to boxes, of course we're talking about outlet box, you go to boxes and you see box conductors number in box 314.16. Also, if you were to keep reading, you'll see that fill calculations is 314.16b. So you know you're in the right place when you're at 314.16. You're like, okay, I'm good. So I want to go there in my National Electrical Code and see what it says. Now here's a little thing, because you're going to be flipping in your code book, and you already know that you're going to go to 314.16, so you feel comfortable there. In your code book online, I sometimes have to jot these down simply because I'm going to be leaving the screen. You're in a test environment, you're not. You're going to have everything right there for you. But me, I'm flipping back and forth. So I'm going to jot down. So we got one device. Doesn't matter whether it's a receptacle or switch, both are devices. We got 2 internal clamps. Okay. And we got 3 equipment grounds. Okay. All right, so what we're going to do, we're going to go to the NEC, and we're going to follow what it said. We're going to go to 314.16. Oops, hold on, let me get off my timer there. All right, so 314.16, and here we go. And so now we're going to get very familiar with everything that's in here. So we're talking about devices. So first thing I like to do is I just go in order. So here's device. All right, knock the first one out. It says for each yoke or strap containing one or more devices or equipment, a double volume allowance in accordance with table 314.16b shall be made for each yoke or strap based on the largest conductor connected to the device. All right, so a double volume count. To be honest with you, they didn't give us anything but a device. So it's a double volume count, so it's an equate to if there were 14s, for example, a 14 would be one conductor, be 2.00 would be our cubic inch, but it's a double volume, so it's two of those. So the device counts as two, okay? And so then the next part was the internal clamps. Well, this says clamps. It says where one or more internal clamps, whether factory or field supplied, are present in a box, a single one volume count in accordance with table 314.16b. So so in our case, we have two internal clamps, but we do what? What do we do? Where one or more internal clamps with factory are present in the box, a single volume allowance in accordance with table 314.16b shall be made based on the largest conductor present in the box. Okay? All right, so I've got two internal clamps, right? It says a single volume allowance. Okay? All right, so do the one. And then we've got, let's see here, where are we looking at here? The next one was equipment grounds. So now we want to find the equipment grounds. Here's your equipment ground. Right here. All right, so it says and this is actually interesting. This is a change. Let me make sure y'all can still see my screen. Sometimes you can't see my screen. Yes, you can. Okay. Bear with me. Make sure I'm on the right stuff here. All right, so we're up to 4 equipment ground conductors or equipment volume jumpers enter a box. A single volume allowance in accordance with 314.16b shall be made on the largest equipment ground conductor. They didn't give us any sizes, okay? And so we only had 3, okay? So we're only taking a single volume count, so one volume count, okay? All right. And that was everything. That covered all of them there, right? Y'all with me? All right. So now let's go back to, I don't know if we want to go back to me or not. No, we don't want to go back to me. We want to go back to the code. I'm wondering in the future, instead of a code cam, I should actually put the code book right there. What do y'all think? Then you wouldn't be able to see the questions, so that's why I don't do it. All right. All right, so we had one device, and we have 2 internal clamps, and we have 3 equipment ground conductors, and we just looked it up. So I've got an answer from Too Cool. Anybody else want to chime in with an answer? Don't be shy. It doesn't matter whether you're right or you're wrong. I want you to try it, and then we will dissect it and look at it and look at how it says, because this is very common on an exam. Okay? Okay, Sandra, Beto. You know what, Sandra? While others are chiming in on something, I want to check something. I'm looking for something, a new member. Hey, Nathan. Thanks for joining us. So I want to look and see here what we're looking at. No, I don't see it. I was looking to see if I had my schedule. I was going to read off what I got while y'all were looking it up, while I was going to have for next week's show. Next Saturday's show, I'm going to be talking AFCIs. So, LM says 3, Carlos says 4. I'm giving Too Cool an opportunity to change his. Sandra says 4. So we've got some 3s, some 4s. Okay, so, hey Victor, welcome to the stream. All right, remember, the one device has a double volume, right? So that's 1, 2, double. The equipment ground conductors, remember, 4 or less than what we're dealing with here is it only got 3. So again, they only count as 1. So we had 3. And then, of course, you have the clamp. In the clamp, where you have one or more, the clamp's not a double volume count. So there's only 2 clamps. 4. Okay. All right. Let me make sure I'm right here. So here you go. You've got 2 clamps, 1 conductor, 1 device, 2 conductors, 3 grounds, 1 conductor, 4. Do you see where we got this too cool? You don't do a double volume count for your clamps. It's just 1 count for the clamps. That's it. You don't do 1 for each clamp. Just 1 clamp. That's it. Everybody kind of with me on that? So I just saw you put 5 there and you worried me for a second. All right, so again, I could have 4 clamps in there. Only count 1 volume, 1 conductor. Okay. Now, interesting about this question is that, again, is your answers were in 314.16 B2, B4, B5. We did that. Interesting enough, again, for those that are in the 2017 code, that did not change. So you don't have to worry about that. You know, again, this is a good example of when you could have shooting from the hip. Are you doing that again? Oh, me. All right. So you can use the 17 code and the 20 code in our program. Okay. So a lot of people say, which should I get fast tracks anyway? I'm just talking fast tracks. They go, should I get the 17 or get the 20? I always say get the 20. If you're in the middle of a code cycle and get, but if you're going to be testing in the 2017, you might as well get the 2017. Okay. I can tell you that the 2017 doesn't have the 2020 stuff in it. It'll have 2014 and 2017. So, choose wisely, we should say, in whatever program you use. All right. Y'all ready to go to the next one? That was a very good one. Very common question on an exam. Just remember, all right, hickeys. 1 volume count. What else? The devices. Okay. And always based on the largest conductor in the box. Okay. Yes. And that's what I showed Sandra when we looked at the code. The grayed out part shows how it changes. It doesn't change for this question. Okay. And the code section didn't change. They just added more onto it. Okay, so it does change when it comes to the 2020 and when you're dealing with, if you want to see that, we'll go back to the code. But yeah, in the code, the part here that's addition or that is different is that up to 4, it only count as 1. Okay, when you get over that, it's a quarter volume allowance shall be made for each additional equipment grounded conductor or equipment bonding conductor that enters the box. So it's a quarter volume, 0.25, that gets added to it, okay, for each additional conductor, okay? So a lot of people say, what's the point? Why does it care? Does it really matter? Well, I think the biggest worry for most people when this got in there was, again, that we're putting all these grounds and everything in a box, and it does take up volume. And I could have 100 in. I'm throwing this out there, but I could have 100 in there, but they only count as 1. But they take up volume. So the advocates for this said, you know what? 4 or less still just counts as 1. When you got over 4, then you're going to have a quarter volume allowance made, okay, for each additional equipment granted conductor. Okay, so a quarter, 0.25 is a quarter of 1. So again, that's just what's changed for the 2020 code. Just make sure it doesn't catch you out anywhere, because if I was writing an exam question for the 2020, and again, I'm not going to write a whole bunch of them on 2020 code when we do this when we're writing exams, because we just don't have a lot of time. We're just making sure that the stuff from the 2017 is still viable for the 2020. I can tell you, because I've sat on those committees. That's about all we really do. Now, they're going to ask us to write some new questions. And so one of the questions I might write would be about this new rule in 314.16 B5. That would be one of mine I would write, just to see if somebody knows about the quarter volume allowance when you exceed 4 equipment grounds. Okay? So, good point, Sandra. Definitely something that people have to think about, most certainly. All right, let me see if I can go back to the browser. All right, good point. So the question, one of the questions was, if your state is behind like 2014. Well, if you're on the 2014, we don't offer an exam prep program for 2014 because Electrical Code Academy, our courses weren't developed then. I used to teach classrooms, so it was different. So our stuff goes from the 2017 on, but that's what I tell people. There wasn't a significant amount of changes from 14 to 17 to really make that much difference when it comes to studying, because you could use the Fast Tracks 2017 or whatever you want, and you're going to be okay. There's not enough significant changes. Now, from 2017 to 2020, there's quite a few significant changes of moving things around that could cause it to be a little bit more confusing, right? But other than that, you could get away with it, okay? Now, incidentally, in our 2017 program, when you do these exam questions, the answers will be for 14 and 2017. So that's why people that are on the 14 will purchase the 2017, because the exam questions have both, all right? So it just makes it a little easier for them. All right, let's go to the next question. That was a good one. Very much something like this is going to be on an exam. Okay. Box fill. Box fill is always on a freaking exam. I'm just saying. Something about box fill. It's always on it. Conductors, something. Always on it. It's a low-hanging fruit thing. All right, y'all. Low-hanging fruit. Low-hanging fruit. All right, so next one. Another one is very common on an exam. Okay, good one here. So a three-phase 25 kVA rated transformer with a 480 volt primary and a 208Y 120 volt secondary is to be installed. Okay, gotcha. It says where primary and secondary protection is required to be provided. So there's no ifs, ands, or buts here. It's required to have primary and secondary. That tells me a little bit. Then it says, what is the maximum standard ampere rating of secondary overcurrent protection permitted by the National Electrical Code? Okay, let's do this. Let's do this. That's my best New York impression. For anybody from New York, I apologize in advance. Okay. First thing I like to do is say, okay, this is, if you watch my transformer video, this is where I'm going to take the primary and I'm going to come up with an actual value for the primary and the secondary. But again, I could just say screw the primary. Right now I'm worried about the secondary. So I do the first things first. Anytime I see 208Y120, I'm gonna remember the little tip I gave you when it says 480, remember 836, and when I see 208, remember 360. Okay, if you forget to do that, then all you got to do is take the 208 times 1.732, and that is 360.25. If you want to break it out to at least two spaces, go for it. Okay, when you're doing an exam, you'll have an answer that you'll know whether or not you're supposed to break it all the way out. But if you want to break it all the way out, that's in. Most people just use 360. But let's use the 360.25 to be uber accurate. We'll carry it out two spaces. Does it really matter? Doesn't matter. But, okay. All right, so you're going to see the obvious example answer regardless of whether you use 360 or 360.25. You're going to see the obvious answer. Okay, so now, what do? We take 25,000, and remember 25 kVA, the K stands for 1,000, right? So it's 25,000. So it's 25,000 divided by 360.25, and that is 69.39. Okay. And I could, if I wanted to do 69.39, I could round it all the way up to 69.4 if I want, but we're going to take it as its value, 69.39. Okay. Denver says, why use 360? because what we have to do is remember that when we're calculating this out to get the answer, we're having to do it by the square root of 3. So when you're doing 3-phase, you're going to use the square root of 3 value against the actual voltage. So we always want to do, for say primary, if it's 3-phase, it'd be 480, okay, times 1.732, and that's 831.36. That's your primary multiplier that you're going to divide 25,000 into 831.36. And for the secondary, since it's 208 3-phase, you're going to do 208. We just did it. 208 times 1.732. And that is 360.25. Okay? That's just what you use in order to be able to work out primary and secondary current when it's 3-phase. Okay? So I tell people to get used to remembering, if it's 480, think 831. If it's 208, remember 360. Okay? If it's 240, remember, I think that's 215. But let's see here. Let's do 240, which you could have 243 phase. Yeah, 415. 415. Okay? That's what you'd use. So you can remember them that way, but it's just so easy to calculate it out that's usually you don't even have to commit it to memory as long as you know the process. All right, so we're going to use that. So that was 69.39. Now, that's our value right now. That's none of the answers right here. That's just our value right now. Now we have to know what we've got to do with overcurrent protection. And remember, the question is asking about how do we size the overcurrent protection, in this case, for the secondary. And we're doing this protection for the secondary for the transformer. This is transformer protection. Okay? So where do we go for that? Anybody know where we go in the code for transform? First of all, get familiar with transformers and get familiar with what article that is. So hopefully you guys that are in the fast tracks are creating your own little flashcards. But if you're not in the fast tracks and you want to do yourself a big favor, guys that aren't in it, so pretend like this is there you go, cool. Pretend like this is an index card. I will put on one side of it, I will put Article 450, and on the other side, I'll put transformers. And so I'll have these flashcards and I'll drill myself. I'll go Article 450, transformers, 210, branch circuits, 215, feeders, 225, outside branch circuit and feeders, 430, motors, 336, tray cable, 338, SE cable, 334, NMB, 330, MC cable, 320, AC cable. You know, you just, boom, 340, UF cable. You'll just go through it, 450, okay? Transformers, okay? 680, swimming pools, spas, hot tubs, 690, PV systems, 700, emergencies, 701. You know, so you just move your way through it, and you're going to be able to go. You're going to say, okay, 701 emergencies, 702 legally required, 703 optionals. You're going to be able to go through 800 communications. You're just going to get used to just pop, 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 bam, 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 boom, boom, pop, pop, pop. So when you get in an exam, you save yourself the time, right? Now in transformers, guys and gals, I usually tell people it's pretty easy to remember that if I get a question that's asking about overcurrent protection, it's typically in an exam, it's typically going to be for the overcurrent protection for the transformer. So then you want to remember a little table in your mind, and that table is 450.3, okay? And that's going to have an A and a B. More often than not, because of these voltages, because of what we're talking about here, we're going to be in B. So if you've got your code book, go to 450.3, and then we'll examine it from there. Okay? I've got my code book. I'm going to do it. And you know, I just realized y'all can't see my code cam. So I'm going to do it, and we'll go look up on the computer. So 450.3 you'll notice that says overcurrent protection. Whoop, whoop. All right, so once we're there, that's what it's going to tell us to use, A or B. B is transformers 1,000 volts nominal or less. We know where we're at, right? All right, so we're going to go down here and we say, okay, we're in B. So then go down to table B. And then now that we're here, I will cut to the code and we will examine it. Okay, in the code, I got to go back to the top because I got to get out of this one here. And let's get into 450. Hopefully y'all can see all this good. All right, so there's A. That is over 1,000. And that's also a tip highlight, folks, for highlighting. In this table, I always highlight, okay, the over 1,000 volts and then the 1,000 volts or less. And I actually used to teach people to do this one in yellow and this one in orange, so that when I highlight it on this table or this table, I correspond to the highlighter. But I don't highlight the whole thing, folks, okay? So anyway, we're dealing 1,000 volts or less because it's 480 and 208, 120, so we're down here, okay? Now, if you remember the question said that it had primary and secondary. It wasn't an option. It said you got primary and secondary, okay? And I've just noticed that y'all are also not here on this one either, so I'm gonna hold on here. Let me see if I can get this one working for you. I see it's going to be problematic for me to do that, so I'm going to remove this real quick. Hang with me, guys. Just hang with me. I'm going to see if I can't get y'all on here. There we go. Whoops. That's not what I wanted to do. I mean, I'm doing this stuff on the fly tonight, guys. Y'all got to at least give me some props for that, okay? I am doing stuff on the fly. Like I'm Jimmy Snuka or something. Oh, wait a minute. He did something to do with murder, didn't he? Never mind. All right, so okay. So here we look at it said primary and secondary had to have that protection. Okay, so we look here, primary and secondary, so we're going to be right here. Okay. And of course, our value was 69.39, so obviously we are currents at 9 amperes or more. So 125%. So we're going to take our nifty calculator and take the 69.39 times 1.25, and that's 86.37. Oops. 86.73. I'm a dyslexic tonight. All right. Now, the next thing that we're going to do is go to see if we have an overcurrent device, okay, that is rated for 86.73. And I can tell you, there's a good chance we don't. So let's go look real quick while we're here. Let's make sure we follow it all out so you all can kind of see how this works. And we'll go to, there we go. All right. Here's our list. We got an 86, we got an 80, but we got a 90. All right, so that's our 90. So let's go back to the browser. And Elwood 690, baby. He's a PV lover, man. He loves that PV stuff. All right, so we choose 90. And there we go. And so that you all, whoops, sorry about that. So that you all can see the math. There's your math. So you see what we did. We got the 450.3b. And then we ended up with 240.6a just to validate, just to make sure. Okay. So in this case, it was, again, you see the 25. And of course, they worked it all out. I just did they show you the whole formula. I basically take the 25,000, and we already know that we're using 360.25, so we save ourselves a little shortcut. But for those that didn't know how you apply the 1.732, there you go. It's on the screen. And then once we had that 69.3 amps, we did it at 125%, which we all did, and that was 86.62. Well, actually, let me double check that. Not that it changes anything, but again, I want to see where 69.3. I always like to check 25%. Yeah, I lost some pennies there by not using the 0.5. So 86.62. This is why I explained to you. It doesn't matter. Let's see. What would it have been if I just did this 360? For those that say, I don't want to mess with that other stuff. 360. 69.4. Okay. And if I would have done that times 125%, 86.8. Okay. And that's 86.6. So the ultimate answer on the exam is going to be exactly the same where you use 360, 360.25, whatever. Okay? Not going to be any different. Okay? I think I had a little dyslexia going on there. So, anyway, not going to change. Good question. Too cool. Hold on. Where's my... That's right. That's right. That's right. Okay. Next question. Y'all doing good tonight. All right. The emergency controls for an attended self-service gasoline station and convenience stores with motor fuel dispensers must be located not more, okay, so this is the emergency control, not more than, okay, blank from the motor fuel dispenser. Okay. Exam prep. So in this case, what would I do? Well, we know right out of the way that we're talking about motor fuel dispensers. Okay. So we've got our code book, and before I go to the screen, we'll go on and just flip through your code book like me. Go to your index, unless you already know what article we're in. We're going to assume you don't. And we're going to go look. And we're going to go under M's. And we're going to be looking for something to do with motor and motor fuel dispensing facilities. Whoop, whoop, holla. I ain't going to 100. Oh, that's your answer? You think that's the answer? Too cool? I thought you were telling me to go 100 somewhere. I thought you were going to send me 100. Hold on. Hold on. All right. So 514 is the article. And here, while I'm back here, I'm looking and saying, okay, it's emergency controls. And it looks like I'm just seeing if there's anything in here that's in like true fashion. All the people in here forgot that we want code references. They're just like throwing up numbers, just throwing up feet, but they ain't gonna give me no code references for all of us out there who's trying to learn together. They just throw a number out there like they're the OG, the original gangster, the boss. Okay? Okay. So we're looking at it here. So when I be honest with you, when I look at something, let me give you a tip real quick. If you're looking in the index and you pretty much know that you're going to be in 514, you look under fuel dispensing facilities, and you notice that it's .4, .7, .16, .8, .11. The first thing that should tell you is that is not a very big article. So a lot of times you're like, I'm done. I'm going right there. Now, if you studied, you did these little flashcards, then you could, if you knew it was 514, you would have saved you some time. You would have gone right there and you would have done what we call the bold scanning technique. And again, that bold scanning technique is powerful because you're looking, you're taking pieces out of the question and you're looking for them in the bolds, and then you're scanning over and you're moving through it quickly. That's a bold scan technique, okay? And this one, the article is so small that I would advocate for that you would simply go to 514, okay? Now, because of what we're looking at here, we're talking about the dispenser and emergency controls and all. Anything relevant that would put me in here would definitely put me somewhere where I feel more like I'm at the 514.11, which is circuit disconnects. Okay, so if I wanted a base point or somewhere to start, if you will. Okay, so I look at it and say, well, that was where I'd get started. But for us, let's just go to 514, and because that's where the code says us to go, so that's where we think we need to go. So that's where we're going to go. So let's go to the NEC. All right, let me zoom this back up to the top. Boom. Okay, so 514. Notice it says motor fuel dispensing facility. But you could always also go up to the table of contents as well if you wanted. But the beauty of a tab is I'm pretty sure, and here's another reason I hate these latest tabs. They're so light you can't even see them. Now, the ones that I have for my 2017 were easy tabs. They're nice, they pop. These latest ones, I swear I think they're counterfeit. They are not as good. No disrespect to the company, whoever makes these things, but my students, if they're as blind as me, these things ain't the greatest. All right, because you can barely see them. You're going to spend more time struggling to see them. They might not even be worth it. Okay, so there is a 514 for fuel dispensing. Okay, so we're going to go there. All right. Okay, so we got everything here, and we start scanning it out and what we're looking for. Okay. And one of the things here is, so we've got some allowances in all of this, but here's your emergency electric disconnect. So this is what it was asked. So I said we were going to go to 11. Okay, so emergency, that kind of goes with our question of what the question actually was. Okay, which said emergency controls. We have to kind of know that we're talking about a disconnect. It's going to kill the power. It's emergency disconnect, if you get me. All right, so here it says fuel dispensing system shall be provided with one or more clearly identified emergency shutoff devices or electrical disconnects. Such devices or disconnects shall be installed in approved locations, but not less than 20 feet or more than 100 from the fuel dispensing devices that they serve. Okay? So another thing that I do when I'm looking for exams is, and this is what let me give you a tip on highlighting. This is a good one to highlight that, but when I highlight, I'm only going to highlight this. That's it. That's the only part of that I'm going to highlight. I'm going to do these and this because see the distance, usually on an exam, I shouldn't say usually, most of the time in an exam, if the question, they're going to ask you, they want to know the feet. They want to know something that sticks out. So most people that write exam prep will write questions and will look for things that are important to ask you questions about. So as you go through, people ask me, how do you know what to highlight in your code book? I get that question an awful lot. What do I know to highlight? Well, what you want to highlight is things that the test questions you're looking at that take you to, because for lack of anything else, you don't really know what to highlight. But I can promise you, those of us that write exam prep questions and things like that, chances are that's the kind of stuff that's going to be used on exams. Okay, so in this case, that's what I would highlight. Okay, so there you go. So it's 100. So let's go back to, let's see if I can get back to the browser. There we go. I am back. Let's do 100. And there we go. 514.11a. Y'all are on the ball. Killing it. Too cool. Has a YouTube handle. Mabrams. That's also your handle in the fast tracks, isn't it? Or in the... I know who you are. All right, so let's go to another one. That's very good, very good. All right, there you go, guys. Let's see who can get it. Remember, give me code sections. Give me code sections. So all 15 and 20 amp single phase 125 volt receptacles outlets located within at least blank of the edge of a decorative fountain shall be provided with GFCI protection. All right, remember the question is 15 and 20 amp single phase 125 volt receptacle outlets. Okay, interesting enough, you know right off the bat this has nothing to do with 210, because in the 2020 code, the 210, if you listen to if you're a member of my YouTube channel that's part of the membership where you join, then you watch as we're analyzing the 2020 NEC. And I explained this in there, but in 210.8, it no longer uses 15 or 20 amp. It doesn't say anything about 15. It still covers 15 or 20, but it doesn't say anything about it. Okay, so I just throw that out there. So that's over. We talk about all that in my special 2020 analysis that we have over on the YouTube channel. In case you're interested in joining that and helping support us each month, we appreciate all of you out there that are in that and contribute every month commitment. We appreciate you, definitely. All right, so first thing I notice here is I'm dealing with what? A fountain, a decorative fountain. Okay? All right, we'll have to go with that. So in my code book, I, first of all, might go back if I didn't know, and you should know what, hey Caleb, thanks for joining. I should know that I'm going to go to 680, but if you didn't know, you have different parts in 680, right? So you could go to the beginning of 680 and look down at the parts, right? And then you could say, oh, look, it's fountains. And then you go to fountains. That will save you some time. That's one way to tackle this one. Or you could go to the back of the book. So we'll just assume you go to the back. And let me explain a couple things too while we're doing this. The index is not going to be your holy grail. I know you've heard me say this before, but if you're studying for an exam and you have to use the index for every question that you get on a practice exam, you're going to have a problem. You really are. You're going to have a problem in your exam. The chances of you passing are slim and none, because you just don't have enough time. So again, not going to stump the fast tracks any more than I usually do. But the reason, there's no secret to the fast tracks. It's just code. But it's the way it repetitiously goes over it and keeps forcing you to repeat and learn and repeat and learn and test on it. Is trying to develop this memory. Because when you sit for an exam, there are just certain things that you're just going to know, right? You're just going to know. And if you answer it right because you know it, then you just bought yourself some time. And then that means the next question, you got 4 minutes to work on it. If you answer that now and quick, then the next question, you got 6 minutes that you could spend to it. So again, there are certain things, I'm not saying you got to memorize the code. I don't memorize the code. But there are certain things that will stick out and you'll remember, right? Like it'll always be ingrained at you that you secure MC cable every 6 feet and then 12 feet from a box, okay? And unless it's 10 and larger and have over 4 conductors, and then you can go up to 6 feet. NMB, you know it's 12 inches of a box every 4.5 feet, unless it's a single gang knockout, then you have to secure it within 8 inches if it doesn't have a clamp. You'll learn these things, and you'll get a test question and you'll just know it, and you bought yourself some time. But you're not going to be able to use the index for everything, okay? I just want to make sure that you know that. That is not going to be your saving grace. And it's great to have the index, but it is not it's not going to be your saving grace. Okay, so I'm looking to see if there's anything in the back here under fountains. And there is, and it says see swimming pools, which I should have figured that much, right? So you go see swimming pools. Let me also talk a little bit while I'm doing this, because I'm doing this kind of methodically slow. Do not have anybody tell you during your study period, whatever you're using, that you need to be timing yourself to 2 to 3 minutes while you're in the learning phase. That is hogwash. In the learning phase, you take the time you need to dissect and study this question. When you get down to the last 2 weeks before your exam, then you can start timing yourself. But you've got to build that knowledge up first. Otherwise, you're going to get extremely frustrated. And we don't want you frustrated. Okay, swimming pools, fountains, and similar. We'll go down to fountains, and it says here, fountains are in 680 Part 5. We know it says 600.7, so that's 600 signs. Ain't got nothing to do with what we're dealing with. So you look here, it says go to Part 5. Okay, so we're going to go to Part 5. Like I said, another little quick tip. I would have gone to 680 and would have gone right to the beginning of 680. And these tabs really suck. I shouldn't say that. That's being mean. That's being negative. God, you can't see them. Anyway, you go back to the beginning, and you know you're in the fountains, and you say, okay, and when I meant beginning, sorry, I meant is go to the index in the front. The table of contents in the front. I'm sorry. Didn't mean go to 680. Go to the front and go to 680, and you can look down and you can see that which part it is. And it'll tell you what page to go to. So you save yourself some time. So I'm in the front, okay, the very front, which is the contents, table of contents. And you go down and it says part, and that's on page 576. So I can immediately jump to 5. And remember, the page numbers in the bottom, code references are in the top. Okay? And I'm talking to you and forgot what I was supposed to do. Man, 576. So I'm going to go to 576. And here I'm at fountains. Okay. Now it's talking about GFCI and it's talking about decorative fountain. Okay. And all this good. So I'm thinking, okay, what do I got to look for? All right. So that's when I want to hit bold scanning. And I'm going to say, okay. And I'm looking at it, fountains. Okay. Oh, and another thing, we've got dimensions here, 20 feet, 15 feet, 10 feet, 25 feet. Now, if you're in a pickle, okay, for fountains, you can look on the page and do nothing but focus on the answer in feet. I'm just giving you a tip, okay, if you didn't know. And bold scanning is looking at the bold headers. And other scanning is targeting is when you're looking for the different parts that are in the question or even in the answer in here, okay? Now, this is for exams. In the real world, I want you to study everything. But for an exam, if you got your times on your hands, I'm looking for things like GFCI protection. I'm looking for 20 feet, 15 feet, 10 feet, or 25 feet. I'm looking for those to stick out to me, okay? And, you know, receptacle outlets, all those things are bouncing around in my head as I'm bold scanning, okay? So you got to be able to multitask of the mind, if you will. Okay, so I'm looking down and I'm seeing, and I'm going to start looking, I see 10 feet, but that's wiring. It has nothing to do with the question with GFCIs. And I'm looking down, I see grounding and bonding. It has nothing to generally have anything to do with this. And I'm looking down, I see cord and plug connected equipment. It's not really what we're talking about. And then I get down and I say, whoa, ground fault protection for adjacent receptacle outlets. Seems like what we're talking about here, that is 680.58. Says 15 or 20 ampere, single phase, 125 volt through 250 volt. Didn't give me 250. Here's just a 125. Located within 20 feet of a fountain edge shall be provided with GFCI protection. Okay, so located within 20 feet. It says within 20 feet of the fountain edge. So again, that's my question. It's 20 feet. So if that's it, I used it. A couple ways I did that was, oh, and let me go back to the main so you can see how I would highlight this, because I would highlight this. So let me see if I can go back and bring on our cam. All right, well, that's about as best we're going to get, folks. All right, so right here, 680.58. I would highlight the bold, and then all I would highlight under that is the 20 feet fit. Highlight the header and then highlight the 20 feet. That's all I would highlight for that. Okay, I'm not going to highlight the whole freaking thing. It's not going to draw my mind to it, okay, when I'm on an exam. I was looking for GFCI, I see it, and then I see the 20 feet. That's all I'm going to highlight. I'm not a big believer in over highlight. Okay? All right, let's go back to code. All right, so again, the answer here then for us is going to be within 20 feet. And there it is, 680.58. Okay, methodical, just methodically move through it. All right, next question. You guys nail it. Okay, the demand factor of any electrical system is the ratio of the maximum demand for a system to 125% of the total connected continuous load of the system, 80% of the total connected non-continuous load plus 125% of the total connected continuous load of the system. C, the total connected load of the system. And D, 125% of the total connected load of the system. Okay, so the demand factor of any electrical system is the ratio of, I do not like this question, is the ratio, this is probably going to be under electrical theory that it is under anything else. Okay, so the demand factor of any electrical system is the ratio of the maximum demand for a system to what? Now remember, I might not like it, but it's a chance this is going to be on an exam, unfortunately. So remember something. When you see a question like this, stop and think. Give me your answer, A, B, C, or D. What do you think? I'm going to tell you, you got to think about something. Anytime I'm thinking of a demand load, the demand is taken away from something. And if I'm going to just take every appliance in a building, okay, then it's going to be what? It's got to come from something. So it's going to come from what? The connected load. Because I take a connected load, and you probably heard me say this over and over again. So the reason I'm bringing this up, and I see Kaz got it. The reason I'm bringing this up is because I want you to remember a couple things. One, you have what's called a connected load. You have what's called a demand factor or a demand load, or you have what's called a calculated load. So before you do anything, you're just taking values at their face value. That would be your connected load. If I ask you for the total connected load of a dwelling, total connected general lighting and general use receptacle load, then that would be the total connected load before I applied any demands of 220.42 would be simply 3 VA times whatever the square foot is, 2 small appliance branch circuit at 1500 VA each, and 1 laundry at 1500. Okay, so I've got 1500 for the laundry, 3000 for at least the 2 small appliances, and I've got the 3 VA per square foot. All of that together, that is called a connected load. Now, when I apply the demands to it, now it becomes a demand load, or when you apply the demand factors to it, it becomes a calculated load. Okay, so again, if it ever gets you confused on something and you're looking at it and go, okay, is this a connected load or is this a demand load? Just remember, connected load is just literally as it sounds, totally taking the value it's connected to the load, taking the load's value fully. All right. And then the calculated load or the demand load is a load value that you obtain after you have applied the demands for it. Okay? So a range. A range would be, the connected load would be what it is, the range value is, okay? That's the connected load. The calculated load or the demand load is after I apply the values in table 220.55. You see the difference? Okay. Just was a little moment there. I figured we'd do that. All right. So there you go. It's in Article 100. There is a definition for it. Okay. But I wanted to take the opportunity to kind of paint you a picture, and hopefully that helps you. Okay. We could have just gone to 100, but I'm hoping that helped kind of somebody out there who was thinking, what's a connected versus demand load, and maybe it helps. Hopefully it helps. Hopefully I'm here helping you do that. Okay. Next one. All right. This one's liable to be on an exam. Get your paper out. Come on. Elwood, are you at home yet? You got your code book? You're not riding in the car, are you? I don't want you to have an accident or nothing. All right? Okay. This is a given now. The motor is on the end of a 25-foot, I should say 25 feet conduit run. Should it be 25-foot conduit run? I am not the one to be talking grammar. I drove my editors crazy on the books that I wrote. All right, so the motor is on the end of a 25 feet conduit run that contains only 3 conductors at an expected ambient temperature of 115 degrees Fahrenheit. What are the minimum size THWN copper conductors required to serve a continuous duty 25 horsepower 208 volt 3-phase motor? Dun dun dun. So a couple step calculation in Texas. This will probably qualify as like maybe a 3-step calculation. I want you all to take your time to do it. I've got quite a few people on here in the 30s. Only very few are commenting, so I'm only assuming that I've got a few that want to learn, a couple that are just there, and of course I know that I've got a couple of my haters in the background just sitting there watching because I can see all the ISPs from everybody. So sit back and hate if you want, or you can join us and chime in. I track everything that goes through my sites anyway, so I know when you're there and when you're not. So it doesn't matter. We're all here to learn. If you can help somebody, help somebody. Come on, speak up. Or type up. Get your typing on. Get your typing on. All right. So first couple things that I tell people. First things first. One thing is the motor. So it is a 25 horsepower, 208 3-phase motor. So multiple steps are going to take place. Okay. Now, so remember what the question's asking us, and don't assume anything otherwise. Okay. Many people all of a sudden now want to start thinking, oh crap. Okay, it's 25 feet. Okay, I got a voltage drop to worry about. Oh God, I'm worried about voltage drop. And then they look at, oh, I got only three conductors. Okay, so I don't have more than 3. I can't have more than 3 current conductors. It says it only contains 3 conductors. Okay, that tells me it's in a metal raceway, so the metal's being used as equipment ground. So okay, doesn't matter. All right, I don't have anything to worry about there. Then they look at the ambient. Okay, so a couple things we got to keep in mind. First thing we're going to need to look up is we need to look up what the FLC is of that 25 horsepower 208 volt 3-phase motor. So that's one thing you got to do. Okay. The next thing we do is we know that we're going to have, so the ampacities that we're going to be working with, we have to realize that 31016 deals with 30 degrees Celsius, 86 degrees Fahrenheit, right? And that's a perfect world. We're obviously not living in a perfect world for this question. So that's something else we're going to have to do. So we're going to have to go to 31015 B1, and we're going to have to get the value for that. So that's another step. The other thing that we need to look at in this question is that it says THWN. It doesn't say THWN-2. So we're not using it at 90 degrees. Okay, we're using it at 75 degrees. Now here's something interesting. This case right here in a branch circuit, we got 2 things going on. We have a motor that's going to be considered a continuous load because it's continuous duty. Okay, and the conductor sizing in 430.22 tells me it's a continuous duty at 125%. But we also have a ambient, okay, that we have to take care of. So we got to worry about the ambient. So we're going to do 2 things here. We're going to compare the issue of what it would be under the ambient condition and what it would be under if it was dealing with the fact that it is just a continuous load for the motor. Okay? You with me? All right. And we're going to see whatever results in the largest conductor. Okay? All right, don't worry, we'll walk it out. All right, so let's do the first things first. Let's find out what the amps is on this. I don't see anybody that's done that for me. And so we're going to do it together. We're going to go, let me write it down here because I have a tendency to not miss it. I am getting old. 25 horsepower, 208 volt, 3-phase. Got it. THWN. I got it. Everything else don't really make a hoot to me. So let's go on and do it. Uh-oh, Elwood's got me something on there. We'll see. He hasn't given me a conductor yet, but he's giving me some ampacity. Elwood's afraid to give me a conductor size. He's not going to go out on a limb tonight. I'm just playing with you, Elwood. All right, so let's go look. All right, let's go. And let me go back to the top. And let's go to 430. Now, I always like to go electronically. I like to go to 440 in my PDF version because I can go backwards. But I don't have that option on the online. I got to go right there, and I got to just scroll to the bottom. All right. So, table 430.250, full load current, 3-phase. That's what the question was. All right. And again, it's just a standard motor. Didn't say anything about synchronous type or unified, so we're going to be in here. And it was 208, and I believe it was 25 horsepower. Maybe that's what Elwood was telling me. Maybe he was just giving me the. Maybe you were just giving me the actual amp. You were saving me the trip. That's probably what you were doing. So 74.8 amps. Okay, that's the first thing we got. Now, while I'm doing this, I want to go to 310.15B1 because we got to do something right with that, that 115 degrees Fahrenheit. So here's B1. That's my ambient temperature correction. And since it's THWN, we're going to be on the 75 degree because that's what the insulation rating is. That's another tip, guys. If you're using the adjustment and corrections and you're using the 90 for adjustment and corrections, you got to make sure that the insulation is rated for 90. If it's not, then you're going to be in the 75. All right, so here it was, what was it, 115? So it's going to fall in this, which means it's going to be 0.75. So I'm going to write that down. I'm going to write that down. That's my 0.75. And that's my multiplier. Okay. All right, let's get here. Let me get back to the question, to the browser now. And I knew what. Hey, Tim, thanks for coming. I know. I was just teasing you, Elwood. You were saving me the trip. You were saving me the trip. I get it. Okay. All right. All right, so now we've got a couple things we can work on. One, we know the ampacity. Okay. So, first things first, if I took the 74.8 times 125%, what does that give me? Anybody do the math with me? That's 93.5 amps, right? Right? Or if I take the 74.8 divided by 0.75, that gives me 99.7. Okay? So remember, when it comes to branch circuits, 210.19, I have to choose the larger of the two. So if it's a continuous load, I take I take the actual load at 125%. It's whatever results in the larger conductor. So I got that value. And then I have the other part of 210.19, A1B, that says I have to take, for adjustment correct, I take the actual load, which in this case was 74.8, and I have to do it to the adjustment corrections. Okay, and so how do we do that? Well, remember, since we're having a 0.75, that I can actually take the actual load and divide it by 0.75, which takes me up. Okay, if I already had a value, I can multiply it by 0.75. That takes me down. So using your division or back and forth to go back and forth to see which way I need to go. You with me? All right, so let's go now to the NEC again. I keep worrying I'm going to hit these buttons wrong, guys. I got so many little buttons going on here. But it does make things easier, I'm telling you right now. I complain about it, but I'm not really complaining. All right, so let's go down to 3, 10, 16. The glorious finally made it. We finally got 3, 10, 16 back. Okay, so here we go. Right here, and it's a THWN right here. Okay. So in this case, we need to see what we got. Boy, I don't like how this thing lays out like this. It's kind of weird, funky how it lays out. Anyway, so it looks like I need a 3. Let's see. See what we got for answers. Whoops. There we go. I got a 4, I got a 6. Got a bunch of answers. All right, I tell you what. We'll let somebody tell us where we go. What do you think? So, Elwood, you think 4 is the answer? Because I don't see 4 as one of the answers, so it's kind of ironic that you would say 4. I will click 4, but I don't know where it is on here. It's missing. Now, Sandra says 6. Interesting. Hold on here. Gotta make sure I'm not clicking the wrong stuff. Okay. I'm going to click 3. Now, remember what I did? So anybody that said 6, I need you to make sure you really follow this, because this is exam stuff. All right? And I'm in the way a little bit here. Sorry. Big old head here. So remember when I said 210.19A1? So this is where you need to take time. And if you haven't watched my D-Rating Demystified, that's a great thing. And I'm getting ready to update that for 2020, by the way. Y'all should get excited. That thing's had over, I don't know how many thousand views. I'm getting ready to redo it. The key here is you have to do 2 things with the conductor. When you have a load, and we know what the load is, it's the motor. We know it's just a load. It's just a load. And it says if it's a continuous load, which it is, that we take it at 125% and we compare that to what it would be if we had to apply a correction. Because that's the way it states it in 210.19A1A and 210.19A1B. And we have to compare the two. Whichever one results in a larger conductor is the one we're going to choose. Okay? In this case, obviously it's more amps, so it's going to be a bigger conductor, so it's just pretty much a given. But anyway, so we did it, 210.19A1. Now here's how we did it. You see the screen? So this is what we did at the first comparison. We just took the load at 125%, which is 430.22, which tells you it's continuous load. And it was 93.5 amps. That's what we did in our math. But then, since there was an adjustment to that, I take the actual load, and I have to make sure that after the adjustment and correction, that in this case it's just a correction, that it can handle the 74.8 amps. Remember, it's got to handle the load. So why do we use division? Because division allows us to take a known amp value and move up and see what conductor we got to get. Because once we get that conductor, then we can multiply and make sure that we're okay to handle the load. Okay, you with me? So 74.8 amps divided by 0.75. Remember, we're going to go up this way. Okay, now if I already was given a 3 gauge, for example, the answer said you've got a 3 gauge. And then what you can do is you can take 3 gauge was good for 100 amps. You take the 100, multiply it by 0.75, and you'll see that you've got a conductor that can at least handle 74.8 amps. This is one that's very common on an exam. They're going to give you the amps, and it's going to ask you what it needs to be. Okay? And in this case, 74.8 amps, in order to make sure that after the application of this correction, it's still going to be able to have enough ampacity to handle the load. What is the load? 74.8. That is the load. So that's a neat trick. Remember, division moves you up. Multiplication moves you back to confirm it. Okay? So again, I can confirm this by going 99.7 times 0.75, and there you go. 74.77, which rounds to 74.8, and that is perfectly okay for this application. Okay, so you choose the ampacity that corresponds with the larger resulting calculation, and you're going to either take the one at 125% for the continuous load, or you do the one and compare it for the corrections based on the temperature. And whichever results in the larger conductor, that's the one you go with. Okay? Great exam question. Don't get that one wrong on an exam, guys. Hopefully I went over that one enough that you get it now. You have to always compare. And it's the same for feeders. Okay? If I have continuous loads, then it would be 125% of the continuous. And if there was any other loads that weren't continuous, like non-continuous, then it would be 100% of the non-continuous. Now, that's the first part. Choose a conductor based on that, whatever that size would be. But then, if there's any type of adjustment or corrections, I have to know what the load is, and then I can actually do what? I can apply the adjustment and corrections by taking the actual load, divided by whatever the correction is, divided by whatever the adjustment is, and then search for a conductor in that column that corresponds with its insulation, like a 90-degree, if it was THHN or something like that. Then once I pick the amp from that table, then I can use multiplication to check myself. So that I can take the amps from that table and then multiply it by whatever the adjustment is, times whatever the correction is, and I should have enough ampacity to handle the actual load, the point where we started from. You get me? Division up, multiplication down. I did my best, guys, to explain that. If I didn't, and you know somebody wants to give me the thumbs down, that's fine, because I don't share those anyway. So again, I've always got that one hater out there who, by this point, if I've taken over an hour of their life and I've got haters sitting in the background, since we got 43 people on, if you're a hater in the background and you don't like my videos, but you're here watching them, joke's on you. I just stole a bunch of your life that doesn't matter to you. But to all you people that are here to learn, it does matter. And that's why I'm here. All right. So let's go to the next one. All right. Here's a good one. Give it a shot. Underground installed service conductors. So we're dealing with the service conductors that are not encased in concrete and buried 18 inches or more below grade level shall have their location identified by a warning ribbon placed at least blank above the underground installation. 8 inches, 6 inches, 10 inches, or 12 inches. So this is one that you'll learn just going through the course. You'll just know. And because you know that it's pretty easy to remember, you'll be able to hit it and check it and go. But I want you to be able to find it. Now, the first thing that I would tell you here is it's talking about an underground installation. Now, one of the tables that people always remember is table 300.5, and that is depth of cover. But you remember that in conjunction with 300.5 is also giving you a bunch of rules. A bunch of rules for how it emerges from grade, how it's installed, trenches, all this type of stuff, backfill, all this stuff's in 300.5. So that's one of those things to remember when you're seeing this question. You dissect it, and this is talking about an underground installation. And you notice it says buried 18 inches or more. This is like, look, it has something to do with being in the ground. So this is an application where you would be in Article 300. Now, Article 300, and these new tabs really are terrible. Have I said that before to anybody? I'm going to recommend that you don't get the easy tabs right now. They're just, I mean, you can't see it. They're so pale. At least would have been better if they had to put white writing on them or something. I don't know. The old ones aren't as bad. The old ones, yeah, the old ones I have are not translucent. Don't get the translucent ones. They suck. You need to get the ones that are solid colors. That's what my 17 is. I mean, I got some counterfeit. Be careful. Make sure you pay for tabs. Okay? If you're not spending over $20 for a set of tabs, you're probably getting hosed. All right, so 300 is your general requirements. Okay? Article 300 is your general requirements. 300.5 is underground. So one of the things that I tell people is highlighting. I would highlight 300.5 underground. Okay? And I would also highlight table 300.5 minimum cover requirements. That's all just the top part of the table on the next page. Okay. And then of course it's not very big. 300.5 is pretty small. It just goes over half a page and then it jumps over to another page. So not too big. Now this is where you would hit the bolds. Okay. So we're talking about what? All right. So look at it and see what we've got here, and see if it's, you know, any answer that we've got in here. So one thing we know for sure, we're talking underground, but what's unique about it? Service conductors. So if I look at it and I'm talking about, and again, also it's really important to understand this marking requirement only applies to service conductors. It doesn't apply to feeders. It's not a bad idea, but why do you think it only applies to service and not feeders? Anybody know? Type something in if you know why this only applies to service. And don't say because that's what the code says. Do you know really probably the real reason why this applies to services and doesn't apply to feeders or branch circuits? Even though you could if you wanted, you can always do it. But why? I'm looking at these answers. I'm very happy. So service conductors, you see it says in 300.5, looks like D3. I think that's the code references. People start giving me code references. It says service conductors, underground service conductors that are not encased in concrete and that are buried 18 inches or more below grade shall have their location identified by a warning ribbon that is placed in the trench at least 12 inches above the underground installation. So you all are perfectly correct. And since nobody gave me a reason, oh, Tim, I'm having trouble with my tabs. The company that was going to make them for me says they can't put all the information that I want on this tab. So I'm trying to find another provider for tabs. If you know anybody out there that makes them, but whoever makes these ones for these easy tabs, these new ones that they've come out with, they're translucent, don't get them. They're going to drive you crazy in an exam, especially if the lighting is bad. You can't even hardly read them. Make sure they're solid. And I know there's a difference. You know why I know this? I think y'all can see the difference here. Well, those greens you can't because it's, you know, but there. See that that's solid color? See how they both, see how that sticks out? Right? Check this out. Now they look like they stick out, right? Until you lift one up and you look at it under the, you can't really see it, under the light. Here you go. See my finger? Wait a minute, hold on. God, I'm struggling tonight. Can't even see which fingers I'm doing here. Oh, I gotta be behind it. See that? See that? See how it's translucent? You can see my finger through it. You see that? Does not work well when it's sitting on a desk. So in a test environment, I can see how that would screw you. Okay? They do make the solid ones because I see them. They're right there. Okay? So if you, before you buy them, inquire and say, are they translucent or are they solid? Because I do not like these, and you know how many tests I've done and how I've trained a number of people. I don't like these. I'd rather have mine non-tabbed if they're going to be this crappy. Okay. Enough of that. Oh, and let me tell you who I got them from. I mean, so that you know not to buy them from them. Hold on. I'll call them out, buddy. I'll call them out. You know, y'all know who I am. I'll call them out. It's called electricalassociation.com. Electricalassociation.com. If that's who it says on the sample tabs that you're going to get in, don't buy them from them. Buy them from somebody else. Those tabs suck. Okay. Tell us how you really feel, Paul. All right. Sorry about that. All right. So, again, answer is 12 inches. But remember, this is service conductors. Why this doesn't apply to feeders or branch circuits? Nobody typed. I'll tell you why. Because there's overcurrent protection ahead of it. Something shorts it out, it's going to trip a breaker. Service conductors, you don't know what's going to happen up there. We have no idea what's on the primary side, whether the fuses, what size is. We know there's none on the secondary. We don't know. Somebody get into that. That sucker just sit there crisping along. You've seen power lines drop and burn down houses and things like that. And so again, there's nothing there. On feeders and branch circuits, we have overcurrent protection. So if there's a short circuit, ground fault, or overload, we're going to trip a breaker. Okay? That's the real reason why we have this marking requirement. Now, could you put it for feeders and branch circuits if you want? Absolutely. Knock yourself out. It's just not required. I don't know why I'm animated tonight. Y'all got me hyped up. All right, there you go. 300.5D3. All right, next question. Which one of the following fixed equipment shall be installed on the critical branch of the essential electrical system in a healthcare facility? Okay, so with the following, which one of the following fixed equipment shall be installed on the critical branch of the essential electric system of a healthcare facility? Okay, so if you've been studying, I dug it, says, oh great, oh good, I'm glad you understand the motors. Cool, hope it helps you out. It's definitely one that you'll probably see on an exam, so I wanted to take it piece by piece and work through it. Let's say, so which one of the following? So whether exit signs, nursing call systems, fire alarms, or communication systems, which one of those fixed equipment has to be installed on the critical branch of the essential electrical system for a healthcare facility? Now, first thing, you savvy code folk, you know that we would probably have a little flip tab for that because we're looking at healthcare facility. And if I was learning the code and I was new, I'd get my little index cards. If you're in the fast tracks, you can use the electronic version and make your own flashcards for those that are in the fast tracks program. Thank you all for that. But you get your little index cards. I also got mine on Amazon as well, Alex. And all I gotta say, Alex, is go and look at it. If it says that it's from electricalassociation.com, cancel it.
Sorry, I don't know that.
I know you don't, Alexa, because I didn't ask her, but my Alexa wants to answer the question, and she probably would have told me, don't buy them from electricalassociation.com, but I bought it through their Amazon because I thought they were a decent price. You get what you paid for. They were cheap. I mean, Alex, they're going to work. I mean, they're on here. They're going to work. It's just, you just can't see them. Just can't see them. All right. But I can't tell you to cancel them. And if you did get them, it wouldn't be the first 20 bucks that we've wasted in our life, right? But the solid ones are so much better. And I don't remember who I got them from. And I can't believe they're cutting these corners. But don't get the translucent ones. Don't do it. Don't do it. Okay. Sorry about that. All right. Question. All right. So remember I said index cards? So index card. One of the first things I probably would do is pick an index card and create and put 517 on it. And on the back, healthcare facility. Because Article 517 is healthcare facility. So that's just one of those that you learn, right? Okay. So first thing I would do is if I didn't know to go, I wouldn't, 517 is not one I'm just going to go bold scanning through right away. I'm looking at the critical branch. That was very much part of it. So I'm going to go to the back of the code book and I'm going to go to healthcare facility. See if there's anything under healthcare facility. Okay. I got my code book just like y'all do. Go look under it and see what you got. And remember, as I tell people, until you get to your last 2 weeks, slow down. When you get in the last 2 weeks, you got to get in the mode. Okay? But again, don't need to do that right now. Okay? You need to find it and look and see if you can find healthcare facility. And let's see what we've got here. All right, I see healthcare facility, so that's there. All right, then you'll notice it's like, okay, critical branch, 517.32. So remember what I've always told you during exam? On your little scratch paper, once you know that it's 517, you write 517 down, but underneath it, you're just going to write the code reference to the section. So in this case, it was .32. All right, then I'm going to real quickly while I'm here, look down and there, see if there's anything else that I need to worry about. So here's one that says essential electrical system. That was in our central electrical system. That was in our question. What is that? That is 0.31C2. So I'm going to do 0.31C2 since I'm already back here. And then I'm finishing it out. Okay. We got critical care areas. Okay, so this is critical care, but we're talking about the branch circuit. Okay, so, all right, but anyway, they're all around the same. And again, critical, the one I like is the critical branch, and that is in dot 32. Okay, all right, so we know we're at 517. We can now go to dot 32, and we've got one at dot 31. See, so we know about where we need to be. So let's go real quick. Again, don't assume that the index is perfect, but it gets you where you need to be. So we're going to go to it, and these tabs are terrible. I won't say that anymore. I won't say how bad they are. I'll just leave it at that. All right. Okay. All right. So we have. You hear my dog? It's my dog in the other room. Okay. So we go to where it says 517.31. It's the equipment for the essential electrical system. Okay. The equipment for the essential electrical system. And that was one of our numbers. Is 517.31. Okay, but we also had 517.32. So we're going to kind of go down it. And that says 517.32, branch required automatic connections. Okay. All right, so you're looking at down that. And then we have life safety, we all have that good stuff here. So branch circuit, essential healthcare facility, which one? Exit, nursing, okay. All right. Now, interesting here is if you look under illumination of means of egress, and you look down there just as kind of just looking, if you're in your code book and you happen to be looking, one of the things you'll notice here that it talks about illumination means of egress, such as corridors, passageways, stairs, landing, and I'm just doing this so we can read it. Hopefully you're following me. If you're not, it's 517.33a. I'm just reading it. Okay? So just bear with me. And you're going down with it, and you'll see. Now, the reason I'm saying this is because 517.33 is the life safety branch. Okay, that is not the critical branch. Okay, that's the life safety branch. All right, but it does afford you a certain part in here that lets you do something. Okay, and we're going to get to it when I get there. So you read it down all the way down. Then it has exit signs. It doesn't say anything in there about anything to do with the critical branch because we're under the life safety branch, by the way. Then you get down to where it says alarm and alerting system. Okay. It says alarms and alerting systems, including the following: fire alarm systems, alarms and alerting systems other than fire alarm systems. Okay. We have fire alarms here. Shall be connected to the life safety branch or the critical. Okay. So we have a bunch of different stuff down here. Okay. But we're talking about what? The critical branch. Right? So when you look at the branches requiring it in 517.32, we simply move down and we're at what? We have the life safety. Keep on getting it. What do we see at 517.34? That is called the critical branch. So take your highlighter and highlight just 517.34. Just 517.34. All right? So in this list here, it's going to give you a bunch of different stuff. So is exit signs on this list? No. Is fire alarms on this list? No. Is communication systems on this list? No. Is nursing call systems on this list? Yes, A4. Okay, so 517.34A4 says nursing call systems, and that's a critical branch. Okay, so and then but Tim says there's a B. What is that, Tim? 517.34B5. 34B5. Not sure where I'm following you, Tim. Are you in the 2020? We're using the 2020 tonight. I'm not sure you're in there. Anyway, so the answer should be nursing call. Well, there you go. So we're doing 2020 tonight. So nursing call system, but we'll see if it shows the 2017 reference when we answer this question. The point here was the back of the index got us to point 32, point 31. Now, this is a great example. This is a great example of what I say to do here. Remember when I say dissect a question? We now know the answer is in 517.34. Go back to the index. Go back. Do this with me. Go back to healthcare facility again. And this is what we mean by dissecting it. Okay? Go back to healthcare facility. Now look at all the sections. Look and see if you see a .34 in there. What this does, it helps you hone in on what things that they might be using for the question and help you. So let's look in here. Let's see if there's anything that's a .34. Again, remember, the index is not the holy grail, but let's look and see. Anything with the .34. It's on section 34 in here. That might have got us even closer. Hey, my dog. No, there's nothing that got us close. So we did a good job, guys. We used .32, .31 to get us where we needed to be because the index wasn't going to give us the exact answer. Beautiful example of dissecting a question, going back and seeing if any of them matched exactly 100% to our question, and none of them did. So you did the right thing. You chose the question. You chose the critical branch. You chose where it said, where's the other one that it said here? It was the, what's the other word we use? With critical branch, 517.32. Oh, the essential electrical system in 517.31, C2. That got us where we need to be, and then we hit bold scanning, and we looked and looked. And what we look for? We look for the term critical branch, but it had to be a part of an essential electrical system, which is broken into a life safety, critical, and equipment. So it's broken into different pieces, right? So anyway, a good way to do that. That was a good one. And my dog's too loud. Sorry about that. So we're going to do nursing call station. There we go. And it was A5. So again, I'm not sure the reference, Tim, where the B came from, because it's 517.34A5 in the 2017, and 517.34A4 is what we've got for the 2020. All right, last one for the night. Unless y'all have some questions, feel free to bring them. Let's look at it. Very common. Oh, B was the answer. Okay, gotcha, Tim. All right, so when calculating the service entrance conductors for a farm service, okay, the second largest load of the total load shall be computed at not less than blank. Okay, so this is not making you do anything. This assumes that you know where to go to do a farm calculation. Okay, let's assume you didn't know. Well, you should know. Somebody tell me what articles has to do with calculations. How about that? Somebody throw that out up there. Let me get somebody to throw me out what article so that I can feel your love that you know what article deals in calculations. So somebody share the love with me here and throw out the article. I know y'all know which article it is. We even got some tables out here. Your index gets you to 517.34. I didn't see the option for 34 in mine, Kevin. But hey, if it gets you there, it gets you there. 220, there you go, Tim. All right, so let's assume that I didn't know to go to 220. And of course, we know we're going to be over in the optional aspect of it because, you know, didn't say otherwise. So we're going to assume the optional. And that's the only one that references a farm anyway for that one. So But what I wanted to look real quick is that back in the back of your code book, you'll notice that it said there is an actual what says farm buildings feeder. Now, of course, we're dealing with a service calculation for a calculation, but interesting that here it's probably going to be service and feeder calculation. But in here, if you were to do that and you didn't know, let's say you didn't know, and you went to the index, there is a farm building feeder calculation, 220.102, but it also says see agricultural buildings. Okay, and remember what I said. Studying for an exam right now means take your time and examine. I want you to go look at agricultural buildings. Okay, remember, save that last 2 weeks to time yourself. Right now, you shouldn't be in a time. Okay, and I'm gonna go to agricultural buildings and see what we got. Just want to see. How many times do you get to go in agricultural buildings when you're looking in the code book? Probably not a lot. So we're gonna look. Let's see here. Agricultural buildings. Then I'm looking under that, and I'm looking under, okay, feeder and service load calculations, 220, part 5. 220, part 5. Okay. All right. Oh, Kevin's saying you probably went to look up the definition of critical branch. That's one way to do it, Kevin. I went to healthcare facilities. So we're trying to see, and that was the logical where somebody might go would be healthcare. But again, if you can find it in multiple, but I just want to get you around it, get you somewhere. Okay? All right? And I always go, what's the plausible choice somebody might choose? So anyway, 220 part 5. These awful, awful tabs. I promise I won't say that anymore. Didn't I already say I promised I wouldn't say nothing about these tabs? Okay, anyway. God, the yellow ones are worse. You really can't see them at all. Gee, that's terrible. Now they might slow you down in an exam. Whew. All right, anyway. All right, let's go to part 5. So, farm loads. Farm loads. All right, so only conceivable thing that shows anything to do with percentages, okay, is for farm loads. And if you look at it, it ends up sending you, okay, because we're talking this case right here, we're talking about for the farm. We didn't say anything about the dwelling. So you look at other than dwelling units, and it sends you to table 220.102, because if it was a dwelling unit, you're going to calculate it whether it's part 3 or part 4, optional or standard. This is just a farm service, so this is for the farm. Okay, so you would use 220.102b, which sends you to table 220.102b. Cool. All right, so once I'm over here, all right, now it says the second largest load. Okay. Now, interesting, you have tables 220.102 and you have 220.103. Now 103 is the farm load total. So it looks to me like we're doing a total calculation right here. Total calc, okay, for the total farm service, okay? So you have dwelling units, then you have things that are other than dwelling units, and then you have the total farm load calculation, all right? You know what? I should do a video on that. I don't know if anybody really cares about a farm calculation, but anyway. So anyway, in this case, we're going to be at 220.103, and it tells me to go to that. Okay. And here it says the largest load is 100%. Second largest load is 75%. And it's asking me for the second largest load. So not a calc, it's just a kind of a lookup, but you have to know the difference between either I'm doing the dwelling, and then I'm doing something that's not a dwelling, and then I'm doing the entire farm load. So this is saying this is the service for a farm. It's everything, okay? And we don't want to, in our mind, think about anything else. It's obviously everything. This is the total farm load calc right here, because it said the second largest load of the total load. So, okay, so that's what would get us to table 220.103, but we got there through 220.103 farm loads total. Okay, So again, we might want to do one of these. I might end up, I think what the most important part of this, when somebody says they want me to do a video on farm load calcs, one of the most important parts of this, I'm going to go to it in the code, is the part that's under that table, which probably explains a lot of anything. Watch this. Okay, so let me go back. I just want you to see it. Okay, so see, here's the table. Here's what we were talking about. And for those who are following along, you have for the farm, you've got dwelling units. You have other buildings that are on the actual farm that are other than dwelling units. And of course, then you're going to have the total farm loads. It tells you how to do it here. But what's interesting is this note. This is what's interesting. It says, to this total load, add the load of the farm dwelling load calculated in accordance with part 3 or part 4 of this article. So you do the dwelling, come up with that's total load. Okay. Then it says, where the dwelling has electric heat and the farm has electric grain drying systems, part 4 of this article shall not be used to calculate the dwelling unit. So it's reminding you that if you have a dwelling unit, then you use part 3 or part 4 to get that total load that you're going to use here, okay? With the other loads, you're going to use them all here. But if that dwelling unit has what? Electric heat and the farm itself has electric grain drying system, which is basically a big heater, then I can't use the optional method. I have to use the standard method to come up with my value, okay? And then I'm able to apply some demands, okay? So maybe I'll do a video on this, but you're not going to get something like that in an exam, but maybe I'll do a video on that. But again, I thought this note right here was very interesting, okay? So, but you get the good direction in here. It says we're supplied by a common service, okay? So that's one service that's going to be supplying both the dwelling unit and the other load. So it's one big service coming to the farm here. Says the total load of the farm for service conductors and service equipment shall be calculated in accordance with the farm dwelling unit load and demand factors specified in table 220.103. Okay, so again, I'll get into some, maybe I'll do an example of this and everything like that, but to answer the question, it was this and this. And I really can't do a farm calc for you tonight because I don't have any numbers that I can throw out to you to do it. So I have to come up with an example and come up with it. Okay. But maybe we'll do something on agriculture if people think we should. Well, heck, I'm game. I'm game for some agriculture. I like 547. I like my crops. Okay. So anyway, 75% was our answer. I gotta get back to the PowerPoint right now. Y'all just looking at code. I'll do something on all code matters. Yeah, I would. All right, so 75% correct. There we go. 2103. I'll do something for agricultural. I get a lot of questions about equipotential for the agricultural and the cows and things like that, but you know what? I need to do a service calc for a farm. I think I'll hook y'all up. All right. So with that said, I think y'all want to do one more, or do you want to end it? Let's do one more. What do you think? All right. Okay. 2 or more motors may be installed without. What's the question, Trey? How do I know if I'm ready to take the state exam? Okay, Trey. Real good question. In fact, since we got time and another question, let's just go on and get back to some questions. It's enough code tonight because I want to. This is a pretty important question. Hold on, let me get back to me, Trey. I think the name is Trey. I'm sorry. Hold on, Trey. This is blocking you. Okay. So, how do you know if you're ready? If you're in the Fast Tracks program, for example, and I'm not saying you are, Trey, but if somebody is in the Fast Tracks program, they're going to know once they get about to Unit 13 or Unit 14, and they're now doing exams. And when you start getting exams, and you're starting getting over 85% and higher on your practice exams, now whether they're ours or online or from some other source, when you're consistently getting over 85%, preferably upper 80s to lower 90s, then you're probably ready. Okay? If you can calculate a basic motor, if you know that motors, single motors that are continuous duty are treated as 125% when you're sizing conductors and doing anything else, then you know you're ready. If you know how to do ranges, or you watch my video on ranges and you fully understand how to do the ranges aspect of it, then you know you're ready. If you're asking a question and you can answer it within 2 minutes, and not overly complicated, we're not trying to ask you to do a big calculation. A basic code question in 2 minutes, because you're down to that last 2 weeks, and you're able to do those, then you're ready. But the big thing is doing practice exams, and if you're getting scores that are 85% and higher, then you're ready. I need to move this. Somebody keeps asking a question. Okay? So, I don't know, when is your exam, Trey? When do you take your exam? Let me get with Trey. Three weeks. Okay, so you're down to 3 weeks. Now, how long have you been studying? What program are you in? You're in a Fast Tracks? I don't recognize the name. So, if you've been studying, how many weeks have you been studying? How long have you been studying? Because you need to be studying at least 90 days and that's a structure. Okay, you're doing the Jade learning? Okay, Jade's fine. So, how long have you been in it? A month and a half, 2 months? Still, Trey. Okay, now were you using them the first time that you failed? I realize there's a delay, so it's probably not good to do the back and forth. 68%. Okay. Well, you've 68%, and you've got 3 weeks before your test. I would focus on. All right, so no sense in purchasing any program. Go to our YouTube channel. You're already on there. Go to the electrical calculations tab, which is the playlist, and watch the range one. Watch the range. Watch the motors, and watch the transformers. If you get a chance, watch part of the transformers. And watch derating demystified. Watch those, and then for the next 2 weeks before that last week, you need to start getting down into where you're going to start timing yourself. Okay, you really start getting down to where you start, timing yourself a little bit. And since you're not 2 weeks out, you're 3 weeks out. Don't be so hard on yourself for the next week. Going to give you about 3 minutes per question. And again, and like Elwood says, I've got a plan for 60-day and a 90-day study plan. It's free. It's on our website. It's on the main website. You see the web address right here, right there. Go to it. It's free. Download it. And again, it's designed for the Fast Tracks, but you can use it for your program that you're in. It works fine. It'll be fine as long as they give you test questions. And then focus on that plan. And especially the part where it talks about the last couple weeks. And you'll be fine. But again, watch the range. Make sure you understand ranges. Make sure you understand motors. Make sure you understand transformer basics. Make sure you understand derating demystified. Make sure you really know when I've talked about 125% of the continuous load and 100 of the non, and how you apply that and compare the two, then 210.19 or 215.2. Those rules are important because that has a lot to do with conductor sizing, and there's a lot of that crap on the exams as well. But you're 68. I don't know what you have to get for your state that you're in, but you're really close. But do some practice exams. When you start getting around 85s or higher on those practice exams, and they're going to be pretty decent exams, then you'll know you're ready. You'll be ready. Most people say you're never ready. Are you ever ready? You know, I like to tell people, those that go through the fast tracks program, for example, if you get up to 13 at 13 and you've been doing pretty good, because unit 8, 9, 10, 11, 12, and 13 is tough. If you get above 85 on them, you're ready. You're ready. Okay? So, anyway, that's best I can give you, Trey. Good luck. I'm here if you need me. You call me. Everybody knows they can call me or actually jump out and you make sure you get the app. Okay? Get the app. Go to our website. And you can download the app from there, and you can communicate me through the app. Okay, makes it easy. Send me a text. Boop, 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 boop. Paul, help. And I'm here to help you guys. I really want to see you succeed. I am a little different, and again, I got my share of haters out there, but I am a little different than normal, as you can tell. I do want to see you succeed. I am not a know-it-all. I learn something new every day. I've been blessed to be able to help people and have people like you that purchase our courses that help support me to do this and to be able to offer this to you. This is why I do it. This is why I do these Wednesday nights. I can't do them every Wednesday, but this is why I give them my time to do it. Okay? And so I'm here if you need me. Download the app. You can always email me, all that kind of stuff. Okay? I'm always here to help if I can. So that's it, guys. I got nothing else for tonight. We're not going to look at any more because, again, it's 9 o'clock and my wife is in the other room. And, again, she's the one that's always suffered. Okay? She's really been the one that suffered with me because I've been like this for over 30 years. Okay? Seriously. All right. Imagine. Say a little prayer for her. She's got to live with me. All right. Appreciate all of you. Until next time, stay safe. God bless. Peace out. Wow, that's obnoxious. I love y'all.